All right, this is number 12 on the practice quiz, 5-1 to 5-4. Use point ratio form, and I gave you point ratio form there. This is slightly different than the general form of an exponential. The one in red uses a and a plain old x. The reason it uses a and a plain old x is a represents the y-intercept, 0, a. Well, imagine if that was your point and you put it into point ratio form. What would go in for y1? A times b to the x minus x1, which is 0. Well, what's x minus 0? X. So if I put my y-intercept into this format, I would get ab to the x. But what this formula that I'm going to circle in a fancy blue there is for, what this formula is for, is when you don't know the y-intercept. You don't have 0, something. You can't use this format. You can't use this. Instead, they give you 2 other points on the curve. Not the y-intercept, 2 points out there somewhere. Your curve will go something like this. And they're not giving us this red y-intercept. Instead, they're giving us 2 other points on the curve, 2, 12 and 5, 64. So you're going to set up 2 equations. I'll do one in green and one in blue. And here's how they go in. Y equals y1 is the 12 times b to the x minus 2. You just use the y and the x that they gave you. So why don't you write out the blue one? There you go. That's the blue equation. 64 is in for y1, and x1 is 5. Technically, I guess we could call this x1 and y1, and this x2 and y2. But we have our 2 different equations. We're going to now solve for b, and we're going to find that you only get one answer. Here's how you solve for b. Both of these equations equal what? And since they both equal y, we can make them equal each other. In the next step, you're going to either divide by 12 or 64. Here's what I typically do. If I know that the problem is about growth, I'm going to divide in the direction that's going to give me a decimal or a number bigger than 1. Because aren't growth factors always bigger than 1? If the problem was about decay, I would divide in the direction that would give me a decimal smaller than 1. Since this problem is growth, I'm going to divide both sides by 12. Because 64 over 12 is bigger than 1. What I'm going to have to do is rewrite C and D below. So let's just keep going with this. Ready? So here we go. The 12s cancel. 64 divided by 12 is 5.3 repeating. All right, so 5 1/3, b to the x minus 5. Next, you're going to group your b to the somethings. In other words, you're going to divide both sides by b to the x minus 5. So you're going in the opposite direction that you went with the number. I brought the numbers to the right. Now I'm bringing the variable parts to the left. I'm removing the variable parts from the right. Now, by making that choice in the previous step, where I divided by the smaller number, I'm going to guarantee that I get a positive exponent in this step. That's good. You could do it the other way. You'll get a negative exponent, and it'll be a little more complicated, though. And here's what I mean. When we have, side note time, a to the m over a to the n, what do you get? So what we're going to have here is b to the blue minus green. Now, it's not that complicated if you treat the letters and the numbers separately. What happens when you do x minus x? It's gone. What about -2 minus -5? You get 3. You get b cubed equals 5.3 repeating. And if b cubed equals 5.3 repeating, cube root both sides, and you get 1.75. Exactly. You pushed 3 a bunch of times, and it came out to 1.747. Okay. So we'll round it to 1.75. Okay? That's called the growth factor. What would the growth rate be? Pretty big. 75%. You knock off the 1 and move the decimal 2 places. The growth rate would be 75%.